Strobel's research ultimately led him to conclude that materialistic explanations for the origin of life were deeply flawed. And his examination of negative evidence did not end with the question of first life. He also learned of weaknesses in the most celebrated icon of Darwinian evolution.
In Darwin's book on the origin of species, there's only one illustration. It's called the Tree of Life. Darwin used it to explain how every species of animal and plant that ever existed on Earth had evolved from the same common ancestor through small, gradual steps over enormous periods of time. Even though Darwin's Tree of Life is included in virtually every biology textbook published over the last half-century, contrary to what we've been told, there is no conclusive evidence of the common origin of all life.
Perhaps the most damaging blow to Darwin's theory is the fossil record. If all living organisms have descended from the same primitive life form, then the rock strata of the Earth should be filled with the fossilized remains of animals that were once part of a great evolutionary chain. A chain of small biological modifications, ultimately leading to a spectacular diversity of life. Yet, after 2 centuries of research, highlighted by excavations in southern China, the multitude of transitional experiments, or missing links, that should exist are conspicuous only by their absence. The most graphic example of this void in the fossil record is a geological era known as the Cambrian explosion.
The branching tree pattern of Darwin's theory is actually not seen anywhere in the fossil record unless we impose it with our own minds. So the Cambrian explosion is the most dramatic refutation of the Tree of Life.
The Cambrian explosion of life was a dramatic episode in geological history. Usually dated at about 530 million years ago, the exquisitely preserved Cambrian fossils reveal that the body plans for virtually every major animal phyla appeared, not gradually and slowly as Darwin had speculated, but instead with astonishing suddenness.
If we imagine the whole history of life on Earth taking place in one 24-hour period, the current standard estimates for the origin of life put it at about 3.8 billion years ago, let's say 4 billion. So if we start the clock then, our 24-hour clock, 6 hours, nothing but these simple single-celled organisms appear, the same sort that we saw in the beginning. 12 hours, same thing. 18 hours, same thing. 3/4 of the day has passed, and all we have are these simple single-celled organisms. Then at about the 21st hour, in the space of about 2 minutes, boom, most of the major animal forms appear in the form that they currently have in the present. And many of them persist to the present, and we have them with us today. Less than 2 minutes out of a 24-hour period. That's how sudden the Cambrian explosion was.
In a geological instant, the animal kingdom leaped from small, relatively simple organisms to extraordinary creatures with spinal cords, compound eyes, and articulated limbs. The record of this explosion of life looks nothing like Darwin's slowly branching tree.
Darwin's theory is that there's a tree of life, where you have one organism diverging into many other organisms and big differences appearing at the top. What we really see is from here up. This does not exist in the fossil record. If I were using a botanical illustration, it would be a lawn with separate blades of grass sprouting independently of each other. And those would be the phyla. Now within each phylum, there is subsequent diversification, but even there, I don't see the branches connecting that would make them a tree of life. As scientists, it's not our job to force the evidence into a theory that just doesn't fit it. And so I have absolutely no desire or reason to uphold Darwin's theory at this point.
I think what we're seeing today is a series of scientific discoveries that are opening the eyes of more and more scientists to say, wait a minute, I can no longer believe that pure naturalistic processes can account for the origin and diversity of life. There must be something else here.
The challenges to Darwinian theory have led more than 600 scientists with PhDs from major universities throughout the world to sign a document titled A Scientific Dissent from Darwinism. It reads in part, "We are skeptical of the claims for the ability of random mutation and natural selection to account for the complexity of life."
These are scientists with PhDs from Stanford and Berkeley and University of Chicago and Cambridge, major universities, who've looked hard and fast at the evidence and walked away saying, I am not convinced. Maybe there's another explanation. Personally, the negative evidence forced me to conclude that Darwinism would require a blind leap of faith that I just had no good reason to make.
For more than a decade, Guillermo Gonzalez has researched the characteristics of a planet required to support complex life. Estimates vary, but a current list of these factors would number at least 20 and include an oxygen-rich atmosphere, liquid water and large continental landmasses, a home star of the right temperature and mass, an orbital path that is neither too far nor too close to the home star, a moon large enough to stabilize the tilt of the planet's axis and the movement of its tides, a magnetic field strong enough to deflect the sun's radiation, and a position in the relatively narrow habitable region of a spiral galaxy.
All these factors have to be met at one place and time in the galaxy if you're going to have a planet as habitable as the Earth, which you need for complex and even technological life.
Theorists have attempted to calculate the odds of all the necessary factors for life appearing at the same time on the same planet. A conservative estimate is 1 chance in 10 to the negative 15th, or 1/1000th of 1/1 trillionth. On those terms, even when compared to the billions of suns and possible planets in our Milky Way galaxy, the probability of even a single habitable world appears unlikely.
There are many probabilistic resources in the galaxy, but on the other side of the coin are all these factors that you need. You have to get just right in order to have just one habitable planet like the Earth. And that leads me to conclude that yes, we're rare in the galaxy.
Gonzalez's study of the Earth's habitability led him and colleague Jay Richards to expand the scope of their research. They began to examine how a life-sustaining planet like Earth may also give its human inhabitants access to the mysteries of the universe.
I don't think there has ever been a time in the history of the human race in which at least some people haven't contemplated these questions. We ask, why can we see distant galaxies, millions of light years away in the universe? Why can we postulate what's going on inside atoms or inside black holes? Why are we able to discover things about the universe, to answer questions about its age? For most scientific discoveries that we're able to make, these sorts of things can't be explained in terms of the survival of the fittest of our distant ancestors. Not only our ability to do science, but the openness of the natural world to science just completely outstrips the sort of reductionist and Darwinian explanations that we're used to.
In response to this evidence, Richards and Gonzalez have argued that our ability to make scientific discoveries is no fluke or accident. Instead, it points to an underlying purpose behind the universe. It is actually designed for discovery.
Guillermo Gonzalez and I spent several years pursuing a hypothesis that those rare things that life needs in a planetary environment, those things that make a planet habitable, also set up the best set of conditions overall for scientific discovery.
There are many examples of this correlation, including our planet's oxygen-rich atmosphere, both a critical requirement for our survival and a transparent window that allows us to explore the distant universe. the Earth's precise distance from the Sun, and the size of its moon and home star. These factors not only control our planet's temperature, axial tilt, and the movement of its tides, they also ensure perfect solar eclipses, phenomena that have provided scientists with invaluable data about the composition of stars and the properties of light. And our location in the Milky Way. The Earth is positioned between two spiral arms within a relatively small region where life is possible. As a result, we enjoy an excellent platform for clear, unimpeded views of our galaxy and the rest of the cosmos.
I think God intentionally created a habitat for us that allows us to see Him through the creation that He has left behind. And this habitat is conducive for us to do scientific research. It didn't have to be that way, but it is. Why? Because I believe that by doing science, we find God.
Since the beginning of time, all the matter in the universe has been governed by precisely balanced laws and constants. During an interview with Robin Collins, a philosopher with degrees in mathematics and physics, Strobel learned how these laws offer compelling evidence for a creator and conspire to make the universe habitable for life.
The laws of physics are balanced on a razor's edge for life to occur. For example, if you didn't have something like gravity that pulled matter together, you would never get planets, you wouldn't get stars, you wouldn't get any complex organisms. If you didn't have the strong nuclear force, there would be nothing to hold protons and neutrons together in the nucleus. And so you wouldn't have any atoms, so no chemistry. If you didn't have the electromagnetic force, you would have no bonding between chemicals. You would have no light, and the list goes on. So you need all these sorts of fundamental principles have to be in place in order for life to occur. Wipe out one of those principles, wipe out one of those laws, no life.
Strobel learned that life also hinges on the precise strengths and relative values of many different physical constants. One example of this fine-tuning is the force of gravity.
Imagine a ruler divided up into 1-inch increments and then stretched across the entire universe, a distance of some 14 billion light years. For the purposes of illustration, the ruler represents the possible range for gravity. In other words, the setting for the strength of gravity could have been anywhere along the ruler, but it just happens to be situated in exactly the right place so that life is possible. Now, if you were to change the force of gravity by moving the setting just 1 inch compared to the entire width of the universe, the effect on life would be catastrophic.
No large-scale life forms could exist. Anything that was more than the size of a pea would be completely crushed. So you might be able to get life of a very, very primitive sort, such as bacteria, but you could never get conscious observers.
The strength of gravity is just one of at least 30 separate parameters that must be finely tuned to produce a life-sustaining universe. Another example is the cosmological constant.
The cosmological constant describes the expansion speed of space in the universe. If space expands too quickly, then the universe will spread out so quickly that material objects can't form. So you can't get stars and galaxies and planets and the types of things that we, of course, take for granted in our universe.
Physicists have determined that the cosmological constant is fine-tuned to 1 part in 100 million billion 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 billion. Such precision has been compared to traveling hundreds of miles into space, then throwing a dart at the Earth and hitting a bullseye measuring 1/trillionth of an inch in diameter, an area less than the width of a single atom.
Just consider those two parameters, gravity and the cosmological constant. Their level of fine-tuning is to a precision of 1 part in 100 million trillion 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 trillion. I mean, that's like 1 atom in the entire known universe.
This fine-tuning is also evident at the atomic level. The strong nuclear force binds atoms together. If the strength of this force were to decrease by 1 part in 10,000 billion, the only element left in the universe would be hydrogen. Again, chemical life would not be possible.